Hello, and welcome to the video on conversions and dimensional analysis word problems. I'm Dr. Cossey, and I teach chemistry and organic chemistry. This particular video is meant for intro chemistry classes and general chemistry classes. For this video, we're going to be practicing using dimensional analysis to do conversions that come in the form of word problems. Sometimes people aren't sure exactly if they've learned dimensional analysis or not, so here's the definition. Dimensional analysis is a strategy. It's just a way that you're going to be able to convert one known quantity into some unknown quantity. So say you want to convert miles into how many hours the trip's going to take you, and you would use something like a rate to figure that out. The way that you solve the problem is done by providing a setup at the beginning where you're canceling units, and that tells you which way to go, and then you're going to do all the math in one step. So rather than having multiple calculations where you have to then substitute, you're going to do all the multiplication and division all at once after you've got your setup ready to go. So hopefully that sounds familiar, because that's what we're going to be working with. So moving forward, assuming you know the basics of dimensional analysis, this video is going to be all about using dimensional analysis to solve word problems. So again, if you haven't seen that before, you want to go back and see a video about the basics or review your class notes. If you've seen my basics of dimensional analysis video, I always like to have a given strategy, so that way we sort of know where we're going. And this is the strategy on the screen. So as you can see, we're going to start with a known or given value. That's something that has a single quantity. Then once we have that, we're going to arrange conversion factors so that the units cancel. That's the dimensional analysis part. And then we're going to calculate the answer, usually in one step, again, not in separate steps. And then we're going to determine the significant figures at the end. And then we'll always check our answer to make sure it's reasonable. So those are the basic steps, and we'll go through those as we do our examples. One more thing is, if we're going to do dimensional analysis, we kind of have to know what pieces we have to work with. So in the problems, they'll be given information, but not everything will show up in the problem itself. So you'll have to know there's some things you're going to have to memorize. So those might be, for my class, it's metric conversions, and some of the English conversions. So like feet to inches, ounces to pounds, things like those are English. And metrics are kilo, centa, milli, all those prefixes. The things that I usually give for my class so that they don't have to memorize them are things that are English to metric conversions, because those are kind of abstract and you can use different ones. Some examples include here for mass, volume, and length. So hopefully this intro part has helped us all know where we're starting from, so that now we can dive into the problems. So here's our first example of a dimensional analysis problem. In this problem, we're going to use some of the information in the given problem to figure out a dosage of a medicine for some sort of patient in some sort of disease. This is something that in my class we see on our worksheet, so it's a pretty similar example to worksheet. So if you see some of these in the future and you're taking my class, they should look familiar. So first things first, you want to read the entire problem so that way you know sort of what's going on, and then we'll start to piece it apart. So pause the video and do that first. All right, did you find all the information? Good. Okay, so what we're going to do is now we're going to take everything that has a number, because that could be some sort of conversion, and then we're going to write them down. That's what I do. So that way we know what we're starting with. So if you look, we've got 135 pounds. That just seems to be a single usage. That's how much the patient weighs. And then there's a dosage of 14 milligrams per kilogram of body weight. That has per in it. What does per make you think? Right? It's a ratio. So that's going to be one of our conversion units. You can write it as a conversion unit where you use an equal sign, or you can write it as a ratio. Just note if you use a ratio that you can flip it upside down, but either one of those is fine. Those are all of the conversions that we have in the problem, so if you need anything else, we're going to have to get it from either the given information or something that you've memorized. Okay, so we'll talk about that when we get to those. But let's start trying to set up the problem. So whenever we're going to set up the problem, there's not a set formula. We're going to use conversions and canceling to try to get where we're going. So we do need to know where we're going. So in this problem, what is our answer supposed to be in? What kind of units do we want? Right? It's going to be this milligrams of medicine here. So I'm going to write here, and I usually write the thing we're looking for, I write question mark, because that's the thing we're trying to get. Does that make sense? So we'll know when to stop. Okay, so now that we've got that written down, where we're going to start. So as we said before, we're going to start with a single unit, something that's usually not a conversion. So we're going to use on this side on the right, we've got the 135 or the 14 milligrams per kilogram. So which one of those is a single unit? just the 135 pounds, right? That's 135 pounds for the patient. Perfect. So let's put that over here, and then we'll write it over 1. And then we're going to either put parentheses, or you can put a grid if you prefer, but I like to put parentheses, and then we're going to go forward from there, okay? So we have to get to the milligrams of medicine, and we're starting with pounds. Now, it's important to know that this pounds is for the adult patient, right? So that's a person. So how are we going to get from pounds to the medicine? Well, we can obviously use the milligrams of medicine per kilogram of body weight. That's what a dosage is, right? It involves the medicine. So let's fill that in with our conversion. Okay, and then that's still not going to get us directly there because pounds are not part of that ratio. So to get from pounds to something that's in metric units, we're going to have to use a given conversion that I would give you on a test, basically. So the conversion factor that we're going to use is this one where it's going to go pounds to kilograms, right? And then we have to figure out how we're going to get that to go with our pounds to get where we want. All right, so I'm going to add one more thing to my blue unit is pounds. I want to make sure I know that's for the patient or the person, however you want to call it, because there's also a weight of a medicine, which is a totally different weight. So I'm going to write pounds of person, we'll say. That's fine. Okay? So now I need to go from the person to the medicine, and the only thing I have that does that should be given in the problem. Because I'm going for 2 different items, they're not even the same thing, right? So that has to be something that's in the problem. So that's where I get the milligrams of medicine per kilogram of body weight. The body weight is the person, and the milligrams is the medicine. Does that make sense? Hopefully? Okay, cool. So then, because I'm going to use that, and this is going to be, I'm trying to get to the body weight, I need to be in kilograms, and that's how I knew I was going to use this other conversion of kilograms to pounds. That's where it's going to go. So when I set up this unit, I'm going to put the pounds on the bottom so that way they'll cancel out, and then I'm going to put the kilograms on the top. So as you can see, I'll highlight the pounds. That's what's going to cancel out. Those are the same. And then I'm going to add in the numbers that go with my conversions. So the pounds needs to be the 2.205 and the kilogram needs to be 1. Okay? So then once I have that one, now I have kilograms. And again, that's of the person, right? So then I can cancel out the other thing, right? So now I can find what can I cancel out is the kilograms of the body weight because that's also the person. Okay, so that's going to go on the top or the bottom? The bottom, right? Because that's also going to cancel. So we'll highlight that one. Those match. So now that's going to be canceled out. And I'll keep my 14 milligrams of medicine on the top. And then where am I trying to go? Right, I'm trying to get the milligrams of medicine. So it looks like I'm there. So that means I can stop. And that's how I know whenever I'm supposed to stop. All right, so now my setup is complete. I've got everything I need to get me the answer that I want, which is in milligrams of medicine. The next thing I need to do is calculate it. So I'm going to use some math. And the easiest way that I think to do this is to do all the multiplication at once and all the division at once. Okay? So if you're putting it in your calculator, it'll be 135 times 1 times 14. So that's all the top numbers. And then we're going to divide it by everything in the bottom. So 1 times 2.205 times 1. And that's what we're going to divide it by. Okay? So there's the math. And then we can do that and set it up like this. And then whenever we do that, we should get this answer. Okay? So hopefully that's what everyone got. Now, the next thing we need to do is figure out how many significant figures we have. So if you already know how to do that, pause the video and try to figure out what you should have. Okay? So if you don't know, let's sort of clean this up so we can see it a little bit better. All right, so I just moved some of the extra information off the page so we could see a little bit better. So I just moved my final answer that we got in the previous part right to the right. And now we need our significant figures. Now, significant figures are going to come from the problem. They're never going to come from the memorized information or the stuff that's on the exam for like multiple problems, because conversions in general are assumed to be exact, meaning they have an infinite number of significant figures, meaning they're not a limiting part. That's not a problem, okay? So for significant figures for the answer for this problem is multiplication division. The rule is that you use the lowest amount. So we need to look at the numbers in the problem and figure out which one has the less amount of significant figures. So the first number is 135. So how many significant figures does that number have? Right, it's 3, right? Because all the numbers are significant. There's no zeros, so we don't have to worry about that. So we just count how many numbers there are. Okay? So the other number in the problem is the 14. So write that down. So how many significant figures is that? It's 2, right? That's 2. So which of those is a lower amount of significant figures? 2, right? 2 is less than 3. So because of that, that means our final answer needs to be in 2 significant figures. So in that case, we're going to round. I'm going to underline where we're going to round, right? So that would be 860 milligrams of medicine. And that's 2 significant figures because the 0 at the end is a placeholder to tell you it's the tens place and therefore is not significant. All right. So hopefully that makes sense. Does that seem like a reasonable amount of medicine? That's the last thing we want to think about. Does that seem reasonable? 860 milligrams is less than a gram, and a gram would be like a spoonful of sugar. Think about that weight. That seems like a normal amount of medicine to have. If you had done the wrong conversion, what happens the most often is that people are going to take the 135 pounds and convert that to milligrams. But that's milligrams a person, right? Not the medicine. So then you would have accidentally given someone 135 pounds or 61 about kilograms of medicine. That would be way too much, right? That would kill someone. So you always want to think about if it seems like a reasonable amount of whatever you're trying to get at the end. All right? Great. All right, so hopefully that makes sense. I know it's a long process, but hopefully we went through it slowly so that way you were able to figure out what you were trying to do. I have at least one more example that we're going to do based on the activities in the class where we're going to use nutritional information. So if that's of interest to you, check out the next video. For now, we're going to end this video here just so it doesn't get too long. And if, like I said, if you want to see the nutritional facts videos where you're going to do things like converting cookies to sugar or crackers to fat, those kinds of things, check out my next video. I hope you have a great day. Bye.